This is a short video describing the operation of digital control valves. This type of valve is used extensively for control of truck, rail car and ship loading of petroleum or chemical products. By using a normally open and normally closed solenoid, it is possible to hold the valve position at any point between closed and fully open. The usual arrangement is a storage tank supplying a pump. From the pump, product flows under pressure through a meter and then to the digital control valve. A preset unit, such as an accuload, download or petrocount, is used to monitor the flow via the meter and then operate the solenoids of the control valve such that the flow rate follows the desired flow profile. This diagram shows a typical flow profile. At the beginning there is a period where the pump is running but the valve is not opened. This line packing arrangement is used to ensure that the product pressure has reached a level capable of providing good valve control before the valve opens. Depending on the type of product to be loaded, there may be a low flow section at the beginning of a load. The high flow rate is used to load the majority of the load. This period may last many minutes or even hours in the case of ship loading. To ensure the flow rate can be stopped at the required point, the flow rate is reduced at the end of the batch to a flow rate from which the preset unit can accurately determine when to remove the solenoid power and stop the load. Control valves come in various shapes and sizes depending on the manufacturer and the application. Some popular valve makes are Avery Hardle, Brody, Daniel and Smith. All of these valves operate in the same manner, using a piston or diaphragm to move the position of the sealing face of the valve. Here we have a valve shown in its closed state. The spring, assisted by the product pressure, is holding the valve shut. Product can be introduced or released from the area above the piston via the small bore pipework with its normally open and normally closed solenoids. The needle valves are used for fine adjustment if the action of the solenoids is too coarse. To close the valve, power is removed from both solenoids. The pressure either side of the piston is equalized such that the spring can close the valve. To maintain a flow rate or increase the flow rate, the solenoid has to be energized. Whilst the upstream solenoid is energized, the downstream solenoid is pulsed. This reduces the pressure above the piston by allowing the product through to the low pressure side of the valve. The high pressure product under the piston then pushes up the piston and opens the valve. So to initially open the valve, we have to energize both solenoids. By holding the upstream solenoid closed and pulsing the downstream solenoid, the flow rate can be increased. Once the desired rate has been achieved, the pulsing of the downstream solenoid is stopped, but the upstream one remains energized. In the high flow stage of loading, there may be an occasional click of the downstream solenoid to maintain the flow rate. Continual clicking of this solenoid indicates that you are attempting to load at a rate faster than the system can provide. When the preset unit determines it is time to reduce the flow rate, the power is removed from the upstream solenoid. It is not unusual for the valve to overshoot the desired low flow rate and require a click or two of adjustment. When the end of the load approaches, the preset unit removes the power at the predetermined point, closing the valve. For good valve control, make sure the solenoids are in good condition. A valve that opens relatively slowly but closes quickly will provide safe loading without wild oscillation, and will also improve the longevity of the solenoids by not having lots of unnecessary clicking. If adjustment of the valve is too coarse for a single click of the solenoid, use the needle valve to restrict the flow through the small bore pipework. Do not attempt to load at a flow rate faster than the system can provide. In this situation, the product pressure will be so low that it becomes difficult for the valve to close and in turn can lead to overrun situations. Also remember to consider the effect of other loading arms that use the same pump. Thank you for watching.